Now, let me tell you a few words about the European Physical Society. Well, the European Physical Society is an international non-for-profit learned society, and it was founded in 1968 after the invasion of Czechoslovakia by the troops of the Warsaw Pact. Well, in response to this aggression, several physicists met and decided that science should be used for promoting peace. And we are still continuing this mission. The secretariat of the EPS is located in Mulhouse, so you see it's here, you have Europe. Mulhouse is here, so it's close to Strasbourg and close to Belgium, where you can find them in the European instances. We have also a point of presence in Brussels in order to lobby with the parliamentary members of the European Commission. And the European Physical Society is an umbrella organization for the 42 member societies of Europe. That means for the 42 national physical societies of Europe, starting from Portugal, Ireland, even Iceland, up to, Finland, Baltic states, Ukraine, that gives us some work these times, Turkey, and so on. Since February 2022, we do no longer exchange with the Russian organizations for evident reasons. We have also 40 associate members. Associate members support our activities. They come from the universities, from some museums, from large-scale research infrastructures, and more recently from physics-based companies in order to help us in achieving our goals. We have also about 30 cooperating societies with whom we have some bilateral agreements. For instance, the American Physical Society or Optica for people working in optics, and many others. We represent 130,000 physicists in Europe. So the missions of the European Physical Society are to promote research in physics by all means, and also to offer a forum for discussion of the societal impact of physics in the technological, economical, cultural, social developments of our society. The backbone of the EPS is made of its 11 scientific divisions and 7 thematic groups that really look after the different disciplines of physics, like quantum electronics and optics, or plasma physics, or condensed matter physics, or nuclear physics, or high energy and particle physics, and so on and so on. And these divisions and groups are in charge of organizing world-leading conferences in Europe. I don't know if you are in the optical world, but perhaps you heard about the CLEO Europe conference in Munich. They also attribute some grants to students and to researchers who need to travel, for instance, for maintaining a good scientific level. And the EPS, through the divisions and also through our headquarters, attribute some prizes and awards, which is good to obtain if you want, for instance, to get the Nobel Prizes in physics, and when you are European. We have also some editing activities by looking after EPL, which is the Europhysics Leader, and the European Physics Journal. But as I told you, we are very involved in all the society, also all the societal challenges linked to developments in physics. This is why we have a Forum Physics and Society, and I will say a few more words a little bit later, looking after how physics evolves and what should be the impact of such or such physical fields in the society. We have a committee looking after equal opportunities, That's important to increase the diversity, inclusiveness, and of course, fight against the gender gap in our community. We have a committee looking after the historic sites. We award the title of historic site to famous places in physics linked to a substantial development of our scientific areas. We have a committee looking after physics education, and I know that this conference, this lecture is in the frame of dealing with education in physics, and our physics education division looks after the improvement of the knowledge in physics between the high school and the universities, how to bridge better these two communities. This is not so obvious. This depends also on the countries. You have some countries in Europe, like the Scandinavian countries, which are really involved in looking after students and pupils when they pass from high school to the university. While in France, in Italy, I'm not so convinced that you have the same attention. Yes, in Italy, well, in France, it's different. So you see, well, we need to look after all these countries and try to find some coherent responses. We have a committee about European integration that looks after cooperating better with the Eastern and Central national physical societies in Europe. It's important to reach the same level of technology and knowledge in physics between at least all the nations of our community, of the European physical community. And of course, I mean, this principle applies to all over the world. And we have also a division looking after physics for development that aims at proposing some grants to early career researchers working in low-income countries or in low-income continents like, well, Africa or South America, in order to help them to keep a good scientific level. We also contribute to the public debate, for instance, by regularly editing a report based on European data that show the importance of physics through the physics-based industries in all fields you can find in life: telecommunications, informatics, material science, energy plants, and so on. What is the role of physics and how it contributes to the turnover of the European business economy? And you can see here, I mean, this number, all the activities accumulated for the physics-based industries represent 16% of the total turnover of the European countries' business economy. So this is not nothing. We rely a lot on the highly dynamism of our young minds. So this means our young students in physics. We have for them the Young Minds Action Committee, which is a huge structure welcoming master students, PhD students, postdoc fellows in all the different countries of our society. And so far, these Young Minds have been able to build up 92 local sections distributed in 37 countries. And you can see here the yellow stars represent these local sections, and you can see the growth rate, I mean the rate of the number of these sections with the years. And we are quite proud to see that our younger students are really enthusiastic and very, very active to form these local sections. Well, to make one of them, I mean, you need just to find a president, a treasurer, a referent who is a professor in your university and has to be recognized as a local section. And the EPS gives money to help you and to organize some events. For instance, to partner with another section in another country in Europe, or directly contribute to the EPS-sponsored conferences. Well, about what I tried to bring as president of the European Physical Society, I put my own challenges on 3 points. The first point was to increase the number of associate members coming from the industry level, the industry sector. As you know, it's important to keep the link with our students in physics, a majority of whom nowadays find a job not in the academy, but in the industry. And we do not want to lose them when they go to the industry. And this means that we have to adapt our own structures and even help them to feel good in the industrial sector. And one way is to diversify our activities for this industrial sector. The second point was to have a showcase event in order to bring together young students and all the bodies, all the representatives of the EPS, so member societies, associate members, division and groups, chairpersons, and so on. And this event is named the EPS Forum, and I will say a few words quite soon. And the third item I wanted to reinforce was the cooperation with Central Europe and reinforce also our actions for physics for development. You know that we are still in the International Year for Basic Science for Sustainable Development. It took place in 2022. It will be achieved by the end of 2023. Last week in Geneva at CERN, so I will be here. And so it was important to offer more grants, more financial support to researchers working in low-income countries. I put ASEPS, that's ASEAN Society and EPS. So we have some collaboration with ASEAN Pacific Society that gathers a certain number of ASEAN national physical societies, like Vietnamese, Chinese, Korean, and so on. Not sure that Taiwan is inside. Perhaps we can discuss this point later. Okay, and we tried to find some common events together, in particular in the domain of the condensed matter physics. So I will briefly show you a few actions for reinforcing our link with the industry. We first sent a survey to several companies working in optics, in telecommunications, in numerics, in energy, and so, etc., in all the countries of Europe. And we asked them to kindly tell us what they considered to be their own needs with respect to our activities. And we received 1/3 of responses. And this helped us to adapt some of our activities, like proposing a better networking between the industrial people or people starting startups to build up startups and make their activities linked with European project or projects funded by the ERC. And by doing that, we increased our associate members, the number of associate members by 10%. Also, quite recently, we built up a new business web platform in order to allow our associate members belonging to the applied and development science of applications in science or making money with physics to interact with the academic people being inside our members, among our members, so the individual members or some of the member societies. And if you are interested, you can go to this email address and network, and you can find some CVs of students, and you can even deposit your job vacancy notices if you need to recruit such expert. The EPS Forum, the first edition, took place in Paris in 2022, and we welcomed almost 500 participants, 184 students coming from 30 countries, not limited to European countries. We had people coming from Singapore, we had people coming from Ecuador, and this event was the first edition of this event was inaugurated by Maria Gabriel, who was at that time the European Commissioner for Youth, Culture and Research. And we had the pleasure to welcome Barry Barish, Serge Haroche, Joseph Kusterlitz, who are all Nobel Prize laureates and also a representative from the European Research Council. And you see the principle is that the first day is dedicated to direct exchange between the students and the managers, stakeholders working in physics-based companies on a certain number of topics: photonics, condensed matter, energy, nuclear physics, and so on. And the second day is to come back to these different topics in physics and to treat them from a fundamental point of view. So usually this second day is opened by a Nobel session, and then it is followed by several parallel sessions addressing each of these topics. And we have also some roundtables addressing the societal questions, how to collaborate better between the member society of the EPS, how to increase the chances for researchers working in Eastern Europe to get some ERC grants, for instance. And the second edition of the EPS Forum will take place in Berlin, at Freie Universität Berlin, at the Henry Ford building. You see it here, and it will take place between the 25th and the 27th of March 2024. The registrations are opened. If you're interested, do not hesitate to apply. And we offer the possibility to support the travel and lodging expenses for 100 students. So, well, if you have some student being representative of Taiwan in this very nice event, you can send them. And the Nobel session will host Stefan Hell, Anne Huillier, who was invited as a Wolf Prize laureate, but I mean, she became a Nobel laureate recently. And she will be here also. And also Klaus von Klistling will be here. And Nicolas Spalding will be the representative of the European Research Council. A few words about other societal issues we are treating. Equal opportunities means how to increase diversity, how to make more secure our events, how to reduce the gender gap. So what I did as president, but also before becoming president of the EPS, I was the chair of the Equal Opportunity Committees. We published a code of conduct for the EPS conferences, protecting the participants, whatever their religion, their skin color, their gender may be. We also installed the monitoring project for gender fairness in physics that aims at measuring, collecting some figures about the women participating in the EPS-sponsored conferences. And the organizing chairs of this conference have the duty to send us some statistics about the number of women participating, either as normal participant or as plenary speakers or as member of the International Advisory Committee or as a chair of the topical area, and so on and so on. And you see, if you can read them in these numbers, that's always around 22%, which is not so good. The only good number, about 30, that's participation of women in the local organizing committee, which is not a good signal because, well, this is just usually some secretary work. And this is not, of course, what we want to promote. We also created a medal for the Minotaur distinction that recognize some noteworthy female physicists being a role model in science, and we have many of them. So we are very happy that more and more women gain in visibility. We proceed with regular interviews of women physicists. Here you have a photo of Donna Strickland, 2018 Nobel Prize in Physics, and we have also the opportunity to interview less famed physicists, but very gifted, and they will become, I'm sure, awarded a lot in the future. Okay, so I've finished the second part of my talk, introducing what is the EPS. I told you during this introduction that we have a forum named Physics and Society, and 2 years ago we organized a forum about what we call the grand challenges in physics at the Horizon 2050. What can each field in physics bring to our society in the future? How will each field of physics supposed to develop in the coming years up to 2050? Well, I mean, we could have targeted 2100, that would have been the same, I think. But in any case, the starting point was to recall that there is an intimate link between the basic science and the societal challenges. One good illustration is what is performed presently in the framework of the International Year of Basic Science for Sustainable Development. From a more fundamental point of view, we have very great equations of science, like those derived by these two giants, Einstein and Dirac. Einstein for the mass energy equivalence, or the relativity, the general relativity equation, linking the curvature of our universe or to the gravitation, or the Dirac equation predicting the existence of matter and antimatter, and making the first link between the relativity and quantum physics. From these equations, in fact, we had the emergence of unexpected answers in many fields that developed during the 20th century, at the end of the 20th century, and now it continues. You see, nuclear fission and fusion linked, I mean, to the first equation, gravitational waves linked to the general relativity, matter and antimatter for the Dirac equation, and I would even had artificial intelligence nowadays linked to the development of high-performance computer and the science of making algorithms. And this is connected to societal issues like how to provide enough energy for the mankind. What about the singularities like black holes, and can they bring something to our future? Matter and antimatter, I mean, allow to deliver some proton beams, but also having antiprotons, and use them for the physics of health. And artificial intelligence raise some fundamental question of can we make a machine resembling or restoring the capacities of the human mind, or even beyond, I mean, building up a superhuman. So it's important to develop science for understanding matter, but this development affect the lives of the citizens. And well, to run on the safe side, the question of ethics, having a certain control on the development of all these issues is important, and we addressed these questions for different fields in physics, entitled like Physics Bridging the Infinities, well, dealing with from particle physics to cosmology, matter and waves, more connected with condensed matter topics, but also laser matter interactions, physics for understanding life, physics for health, physics and sustainable development, physics for secure and efficient societies. And this project involved more than 70 scientists. So, and this was the objective of these grand challenges in the Horizon 2050. So we published an issue in our regular review journal, Raw Physics News, which is a vulgarization journal, but well, of a certain level. If you can have a look at it, I mean, you are welcome to download it from the internet, and you will see that these different topics have been addressed. For instance, for physics bridging the infinities, you can see that we start from the discovery of the Higgs boson, the experimental discovery in 2012, with a large Hadron Collider at CERN. This revealed the first asymmetry between matter and antimatter, giving a nature to the mass that makes us, in fact. What are the challenges? The challenges are understanding dark matter and dark energy, understanding the nature of the neutrinos. This escapes the standard model, and the gravitational waves. We have no quantum theory of gravity. Developing astronomy with multi-messengers, not only with optical light, but also with gravitational waves, for instance, nuclear physics, the study of exoplanets. And for all of this, you need observational means, but also computing means. In the basket of the matter and waves, the main perspectives are open towards the study of quantum many body systems, where you need to treat the interaction of more than 3 bodies. But at the quantum level, when the material undergoes coherent interactions and interactions with light propagating, and when you have the notion of light and particles, so this is also linked with electron holes dynamics, polaritons, plasmons, and so on. New materials like metamaterials, through which, I mean, you can change the propagation of light, manipulating atoms and photons at the nanometer scale. So this opens a way of manipulating matters at the quantum level. Extreme light, so this is linked to what I first introduced in the first part, laser matter interaction with the very intense lasers, like those you can find in the HeLa infrastructure, or even in Korea, for instance. Extended classical systems, so having many body interactions with numerous degrees of freedom to understand life itself. Physics for understanding life is something that develops more and more. It started with Schrödinger, even by other famous researchers, but let's say that Schrödinger published this book, What is Life? At the beginning of the 20th century. Questions the role of the life being a succession of out of equilibria processes, and how it could respect the second laws of the thermodynamics. And this question was later addressed by Dyson more recently. And then we have many questions about the understanding of life, how life began on Earth. You know that you need to fulfill Earth-Sun connections to a good balance between the role of CO2, magnetic activities, the source term, so the energy that was brought to this prebiotic ensemble. The role of the liquid water is or seems to be very important to develop life. Okay, all are these questions which are not solved for the moment. Life for understanding new physics, it happens that treating more and more complex systems may reveal some new physical laws in the future. At the beginning of the 20th century, we started to study Brownian motions of molecules in a glass. Now we need to describe Brownian motions of pollen grains, take into account the cell motility, all the complex motions of this particle, how to understand animal motion, how to understand the various behaviors of active matter, and the evolution of bacterial populations, and so on. What is the role of the physical information, of the entropy in biology? What is the nature of the human mind? Role of the artificial intelligence? What about consciousness? No answer. Can we build artificial life? This will be also a challenge in the future years. And what about extraterrestrial life? You know that you have some radio telescopes looking or or telescopes even, looking at trying to detect some molecular or biosignatures outside our universe or our solar systems, but this is not so evident, of course. And the search for exoplanets is limited for the moment to infrared spectroscopy, but we can hope to get better diagnostics in the future. For instance, we have 3 Earth-like candidates near Proxima Centauri, which is at hundreds of thousands of years light, but these are scrutinized in order to know if such candidates could host the life. Grand challenges: physics for health, using particle accelerators for treating tumor cells, using robotic systems at the nanoscale, how to introduce nanomedicines or nanocarriers to cure better the human body, using light for health, how to develop the different ranges of the electromagnetic spectrum to cure people, for the imaging techniques, for helping also the diagnostics. Free electron lasers are used to deliver different light sources. We talked about terahertz spectroscopy for having a broad landscape of molecular signatures. This may be used also for improved means in treating biology. And the pandemics, how to model the propagation of pandemics, and this was very in vogue, in particular during the last COVID crisis. Physics for environment and sustainable development. We need to develop more involved nonlinear physics models to model the climate and to simulate all the interactions of the drivers of climate, the cloud, Gulf Stream, the interaction with the sea, and so on. That's not so easy. The energy, you know that you have a very tight connection between the energy sources and the climate change. And this has profound political and ethical consequences. How to store the energy, what is the future of the hydrogen batteries, what will win in the future between the solar source, the wind source, nuclear fission. What about the future of the nuclear fusion? We addressed this point at the beginning of the talk. The green cities, green transports, how can we improve the performances of batteries and fuel cells? How to improve the environmental safety. That means how to guarantee to the human beings to consume good air quality, to drink safe water, and so on. And also the research on space weather to understand better the influence of the sun on the Earth is very very important. So all of these open a huge variety of topics for the future. In physics, you have also physics for secure and efficient societies. Quantum computing, sensor development are becoming more and more the objects of intense research. In Europe, but also in China and everywhere in the world. And of course, this will grow in the future. And with that, I would like to thank you very much for your attention. And
yeah, thank you. Thank you so much, Professor Bergé, for a very, very detailed and comprehensive lecture. First, about your work. I mean, it's amazing to see how things have developed in your field. And look at your examples and pictures. I sometimes I wonder. Actually, I always wonder how you can do the diagnostics. Anyway, let me see any questions from the audience first. If not, I have a number of questions. A number of questions. Yes. First means that, right? I mean, this laser fusion is one aspect of the possibility. How promising that is. I mean, is there a race between laser fusion and tokamak and other things?
Alors, yes, I can answer you. All the more that
you might want to gamble which one I should put my money on.
As you know, I mean, perhaps you don't know, but I mean, the CEA hosts the megajoule facility in France, but this means also in Europe. So that's the real equivalent of the NIF facility in the US, which is in Europe, megajoule. So this is laser fusion. And at Cadarache, which is another, so megajoule laser is located in Bordeaux, yes? And at Cadarache, you have ITER. ITER, that's the magnetic tokamak, the magnetic fusion, which is exploited as a future source of energy. And when you talk with the director of the ITER program, of course, he tells you, well, we will realize the plasma in 2025, 2030, we can start to exploit this machine to get some energy, and in 2035, okay, everybody will receive some energy from nuclear fusion. It happens that the NIF made a very huge breakthrough by demonstrating the break-even. The break-even demonstration came from the laser community last year. But you know, the principle of making nuclear fusion in a magnetic way compared with a laser is completely different. When you use a tokamak, you make a plasma over 1 second. So you have to confine your plasma over long times. And this is better, of course, to extract potentially some energy from the system. But people working on that facility are meeting some usual problems of instabilities at the layer, I mean, at the board of the wall of their torus and so on. Of course, they will manage to solve that. But once they manage to solve that, for sure, it will be easier to extract energy. Laser fusion, you see, you make a plasma, but over a few nanoseconds. So you need to put a target like this over very rapidly, and to change your target to shot into some of them very rapidly to get something significant in terms of energy. So that's the main difficulty. However, and also the difficulty comes from the repetition rate of the laser that can trigger this fusion. However, you have to know that in both communities, you have many startups emerging, arising, and selling already some means to produce some energy for direct use for the populations. So for sure, there will be something. I cannot answer and I don't want to answer who is going to win the race, because both means have qualities and drawbacks. But for sure, this field is meeting an acceleration stage from a technological point of view, and I am sure that in a few decades, I mean, there will be some use from a technological solution for using one of them, even both, for the mankind.
Because I read recently, I think just yesterday or the day before, that Japan is building the largest tokamak facility. Seems that they have made up their mind where to gamble.
Well, I mean, the largest was ITER, but all the member states of the ITER community have the freedom to use their own facility. This is the case for China. This is the case for Russia, and why not to Japan, because I imagine they are part of the game. Yes, they will, but I mean, they will face the same physical problems that they will have to solve them, and in any case, they have to produce a plasma to keep it stable and to extract some energy from it. And then they will have to solve the same problems, heating problems and so on.
Now, our participating listener, if you have questions, you could raise your hand or write it down in your. Yeah, Dr. Liu Shenyuan, can you see he said very impressive activities. Can you, Shenyuan, can you speak it out and tell that to Professor Bergé? Let me look at the chat box.
So I have a question on the Russian-Ukraine crisis. Okay, I can answer. It happens that the war in Ukraine started on the 24th of February 2022. And on the 26th of February 2022, we, with the executive committee members of the EPS, decided to freeze all relationships with the Russian institutions. The problem is that all researchers in Russia are affiliated to governmental institutions, and we wanted to be clear that we stopped to our regular cooperation with Russia. So this was clear. It was easy to do that in the context of the learned society. It was more difficult to have such a clear position for other learned society like the International Union of Physics and for pure and applied physics, IUPAP, because they have a strong Russian participation. And of course, these raised serious problems in large scale in research facilities like CERN or like ITER, where the Russian committee is very, very active. So if I'm not wrong, at CERN, they also edicted some severe constraint of collaboration with Russian physicists. In ITER, it was less evident because, you know, I mean, each member society has a dedicated task and the program could not be stopped like this. But anyway, this put some troubles in many places, this Ukrainian crisis. Well, from the point of view of a learned society, I would like to say that usually we recommend, when we organize a conference, that first we do not invite Russian physicists having an affiliation in Russia. Okay, that means that I can find some other affiliations in Europe, and they are welcome, but we are quite strict. So yes, we have some difficulties, and we can only hope that the difficulties will be raised in the very, very next future.
Okay. All right. I'm just curious about, you know, you have this Horizon 2050 challenges. Why is it 2050 and not 2040 and not 2030?
Yes, this is what I said. We could have told that Horizon 2100. That would have been the same, I think. Well, I'm not sure that we will solve the problem of the dark matter in 30 years, or in 40 years, or in 60 years. I cannot know. Well, we chose, I mean, this number like this just to give a fixed decade. That's the only response I can tell you.
So one of the grand challenges is physics for environment and sustainable development. And yeah, where do those fields belong to in your divisions?
Interesting question. Interesting question. Yes, you know what is turning in the discussions, the current discussions about the use of nuclear power. Until a recent past, I mean, you know, the nuclear power was really criticized, contested. There were a lot of demonstrations in the street against the use of nuclear power plants. It happens that today you have less of these demonstrations, because it happens that, of course, we have nuclear waste to treat. But apart from that, when you have a secure facility, a secure nuclear plant, this is a way to distribute some energy at a relatively cheap fare, and which is clean. You do not emit any greenhouse gas, and you do not pollute the atmosphere compared with using coal. So France decided to develop its park of nuclear plants, and I think personally this is a good choice. When you compare with Germany, they are in a more difficult situation, because they decided to reuse coke in very broad quantities. So how it impacts? Well, I mean, developing new facility of nuclear plant, what we call the RMS, or the small module of the next generation of nuclear plants, are something which are being developed by the CEA, and not only by the CEA, but also in Sweden, in several countries that are in principle ecologists. So you see, the activities of working on nuclear energy are intimately linked to this question of environmental issues, and offering an energy production with zero carbon, you see.
Mm-hmm. Right. I think that this is a topic that also of great interest to us here in Taiwan. So maybe let's discuss in future whether there could be some joint forum or joint meeting, on this topic with EPS, right? And if you agree.
Yes, it happens that we have a new chairperson of the energy group. And in this energy group, you have people coming from different communities, being in favor of solar energies, wind facilities, or nuclear, or even thermonuclear. And why not? I mean, we could imagine to make a meeting. We have also a technology and innovation group working with the energy group. So what about organizing something online?
Yeah. Because some for other fields, you're way above us, But for the energy problem, we are all stuck in the deep holes.
Super. Super.
Right.
That's a very nice invitation, and I appreciate. Yes, for sure.
Look, I think that we have to stop here because it's way past the time. But this is a very wonderful and very interesting, lecture. Okay, great. Thank you so much. Yeah, I hope to talk to you. We will arrange that online meeting. Yeah.
Okay.
Thank you.
Thank you very much, Wing, and thank you very much, Luc, and thank you very much to everybody who attended this lecture. Thank you.
Nice day. Yeah. Bye-bye.
Ciao.